We continue our conference, international conference on trends in electronics and health informatics. Today is second days of conference, and we start our sessions. Sessions themes is neural network modeling and computational intelligence. Session chair, Professor Rahvendra Singh, PICIT, India. Session moderator, Rashidov Akbar, Samarkand State University. Session coordinator, Parmanov Behruz, Samarkand State University. If are you ready, we can start our sessions. First authors is Mohinsa Hidirova, Abrorjan Turgunov. Abrorjan Turgunov, can you hear me?
Yeah, I'm hearing you.
Are you ready?
Yeah, I'm ready.
Okay, if you're ready, you can start. Article name is Qualitative Analysis of the Model of Recurrent Oscillatory Neural Networks. You can start, please.
Okay. So, can you see my screen?
Yes, your presentation is visible. You can
Okay.
start.
Hi everyone. Our topic is modeling cell division in biobatteries, and this article is created by Mohni Sohidirova, Abrajan Turgun, me, and Salahuddin Nasruddinov. Okay, let's start. So, let's start from abstract. This article presents a mathematical model of regulatory mechanisms of cell division in the context of optimizing biobattery performance based on microbial fuel cells. And key features are system of non-linear functional differential equations with delay and three-level control mechanisms, strong, medium, and fine control, and also describes cell behavior under changing environmental conditions, and also enhance energy efficiency and longevity of biobatteries. So let's start by modern energy storage technologies. We have some traditional technologies. They are solid-state batteries. It enhances safety and durability. It provides us, and also lithium sulfur batteries. It provides us higher energy density, and also we have some traditional technologies like flow batteries and metal air batteries, and they provide us scalable energy storage and also very high energy density. And also now, at this moment, we have some emerging technologies like capacitors. They provide us with fast charging and discharging, and also hydrogen storage, long-term energy storage. They provide us, and also gravitational systems. They provide us long lifespan, and also biobatteries. This provides us sustainable and biocompatible energy storages. And also, we have some challenges of cell divisions in biobatteries. They are overcrowding. First one, it causes dense biofilm formation, reduce substrate access for inner cell layers, and also we have some challenges about dead zones. This means cell death in resource limit areas creates resistance on a node surface, and also we have waste accumulation. It provides us metabolic byproducts, increased local acidity and system degradation, and also we have reduced metabolic activity. It provides aging cells, show decreased division rate and energy production, and also genetic mutations. They changes in electrochemical properties, reduce predictability, and also we have some challenges about maintenance requirements. This means regular biofilm monitoring and replacement needed. And the method, let's talk about the mitotic cycle. It gives us phase of cell divisions. First phase is G1 phase. It's also named pre-synthetic phase, preparation of genetic material, DNA for division. And the next phase is S phase, is synthetic phase, it's DNA and nuclear protein duplication. And the next phase is G2 phase, is post-synthetic phase. It provides us cell growth and formation of double amount of organelles. And the next phase, M phase, is mitosis, actual cell division occurs. And the last one is GO phase, it's preparatory phase. Cells either enter new division cycle or perform tissue-specific functions. And also we provide some mathematical model. This gives us system of equations. Here you can see the formula of gene growth dynamics, which were created by us. And here XF, XP, and XM represents functional, plastic, and mitotic gene groups. And also we have mathematical model for concentration dynamics. It's mRNA and protein concentrations. Here you can see our also DNA synthesis formula. Key parameters are R is mRNA concentration, P is primary proteins, E is enzyme proteins, and D is DNA amount here. And also we have the diagram of three-level sequential control mechanism. Here we can see the strong control, medium control, and fine control, and target state. And strong control is altering parameters at transcription level. It means RNA synthesis. And medium control means change at translation level. It's polypeptide synthesis. And fine control is adjustments at protein enzyme level. And also we have model parameters and variables. Here you can see the parameters and variables which are used in our article, and they are XF, XP, XF. We have already told about that, and also RE, PE, and EE. They are concentrations of mRNA and primary proteins, and also enzyme proteins. And have some other variables. Here you can see in the list of them. Okay, the next one is simulation results and system behaviors of our article. And also four functional modes identified as a result of our research. And first one is stationary state, stable equilibrium with constant cell population. And the next one is Poincare type limit cycles. This means periodic oscillation in cell divisions. And the next one is chaotic dynamics. This means adaptive behavior for changing environmental conditions. It increases cell resistance to stress and also optimal resource distribution and also enhance longevity and stability. And the last one is black hole effect. It's uncontrolled growth leading to microorganism deaths. Key finding in our research is controlling the cell cycle and its phases can enhance energy efficiency and longevity of biobatteries. And advantages of biobatteries. Let's talk about the advantages of biobatteries. The first one is environmental benefits. They are used organic and biocompatible components. Its next one is reduced dependence on heavy metals, fewer toxic wastes, and also can use organic waste as substrate. And operational benefits we have, they are self-regeneration capability, safe operation, room temperature operation, low maintenance requirements, and also cost-effective materials. Let's talk about applications and future directions. Current applications are low power sensors and remote devices, medical implants in ecosystems, waste treatment and energy recovery, agriculture and food industry. Future resource directions will be genetic modification to enhance stress resistance, and also development of multi-layered or porous electrodes. And the next one is optimization of medium composition for controller division and integration with multi-species microbial systems, and also coupling cell cycle regulation with metabolic pathways. As a conclusion, we will talk about the key achievements of this research. The first one is we developed a comprehensive mathematical model of cell division regulation, and the next one is established three-level hierarchical control mechanism, and the next one identified multiple functional modes of system behavior, and the last one is demonstrates potential for optimizing biobattery performance. Let's talk about the impact in the industry. The proposed approach opens new prospects for developing biobatteries with high stability and performance for environmental sustainable applications. Thanks for your attention.
Thank you for attention or conference attendance. Do you have any questions in Zoom and auditorium? No. Thank you. I think no questions.
Thanks.
We start. Okay, thanks. We start next authors. Ruslan Abdukadirov. Theme is solving the equation of mathematical physics via quantum physics informed machine learning methods. The others is here and starts in 1 minute.
All right. So glad to see everyone on this conference. Thank you for the opportunity to take a part. Today we'll present to you the method of solving differential equations by neural networks. Next slide. I suppose not everybody likes to solve these difficult equations, especially using the exact methods. For that reason, very long time ago, they were proposed the approach which is numerical. If we cannot find the exact solution, so maybe we find numerical, which will be approximately satisfy the conditions of equation. And in the slide, you can see that in 1700, they will propose the first numerical method, finite difference method. This method served for solving tasks very long, but in 16th, they will propose the advanced approach, finite element method. In the beginning of 2000, they will propose finite volume method. Unfortunately, numerical methods, they have many disadvantages because we have to use mesh. Mesh is a set which puts more errors in the final solution. For that reason, scientists came up with the idea why we have to solve this equation. Why we do not train machine which will solve us instead. And for that reason, they were proposed a physics-informed neural network, which is in 2017. And next, this approach show its opportunities and free mesh approaches. And later, it attained the neural operator and physics-enhanced neural networks. Next slide. So let me explain you how it works. We take variables, spatial and time variable. We put this in a classic neural network, which can be a multi-layer perceptron, which can be a recurrent neural network, anyway. This neural network builds solutions, U1 and UN. This solution we put in equation, we see what is equal and also under initial and boundary conditions. And this solution we check. If solution gives us requested accuracy, then we end the training. If solution doesn't satisfy the required accuracy, then the loss function we optimize it and restart again until neural network attains exact solution. Next slide. For example, here I demonstrated the generalized formulation of a partial differential equation. Here, initial condition and boundary condition. Boundary condition can be Dirichlet, Neumann, Robin, and many others. And here we have the variables and the partial derivatives over time, double time, and the spatial parameters. Also, this equation is inhomogeneous, which makes solutions more difficult. But by expressing this equation through the function of f, and next slide. And we put this equation through the neural networks, which I demonstrated as a neural operator. So every node of physics from neural networks is represented via universal approximation theorem. And this approximation theorem brings us to final solution, which can be expressed as a neural operator. So but we decided to make experiments with quantum neural networks, where we use the combination of classical neural networks and quantum. On the classical neural network, we decided to use the multi-layer perceptron, which is usual universal approximation theory. Under quantum neural networks, we decided to use the cross-mesh architecture, which contains Pauli eventals and the CMOS logic in. And this approach allows us to analyze the behavior of the physical properties of equation in quantum level, and especially let us to find solutions which may be doubled and split into superposition. And this superposition let us choose the most appropriate approximation for our equation. After we get U1 and Un, put it under automatic differentiation and build the solution. If solution is exact enough, we stop training. If it's not exact enough, then we restart again. Next slide. So this is mathematical formulation of this neural network, of the part of quantum neural network. Here we use elements of quantum computing, where we have bra vectors and ket vectors of 0 and 1. But the formula is very difficult. I think I will explain it later after presentation. The most important that this approximation formula combined with the universal approximation theorem and receive the final solution. Next slide. And for correct solutions, we will estimate it by loss and L2 here. L2 is a Lebesgue norm in functional analysis. You can know it as a norm which is a square root of the integral of a square function And by this matrix and these matrices, we will estimate our final solution. First we solve a Burger's equation. Here we have its description and initial and boundary condition. The boundary condition is Dirichlet, which makes the solutions not so difficult. And on the figure A, you can see the solution which quantum neural network gave. And on B, you can see the difference between the exact solution and solution which we received by neural network. As we can see, in the domain of x equal 0 through entire domain of t, we have little blips. It is normal for numerical methods and for physics and form machine learning. But we wanted to compare this quantum approach with classical. Look here, 10 power minus 3 and 10 power minus 4. The error is less by in 10 times. The Lebesgue norm also less than 10 times. However, moreover, we took less time for training because quantum neural network allows to build solution in less number of epochs, then we have less number of training. It makes us to include quantum approaches not only improve the accuracy but accelerate the solution, the solving equations. Next. Another example, more complex, it is Allen-Kahn equation. Here we have it is inhomogeneous and also initial and boundary condition more complex. And in this case, we also see that the quantum approach shows better results and it works faster. And this is the solution which we received by neural network, and there the difference between exact and approximate solutions. But in this conference, I wanted to make experiments on more difficult approaches. Somebody knows about fractional derivatives. You know what is derivative? Fractional diffusion equation, because here we have a derivative which has a fractional order, because in this equation is Kakuto derivative, which is demonstrated via this integral formula. This equation becomes more difficult, but it describes the physical phenomena of diffusion more correctly and exactly. And in this case, we requested more number of epochs and attained a solution which can be estimated in order of 10 minus 6 if in m mean square error, and in 10 minus 3 I made a mistake. Here solution is better. My bad. And here the solution which we got from neural network, and there the difference between exact and approximate solution. And as you can see, the difference can be estimated in 10 minus 4, in 10 power minus 4. These results were also published in journals: Elsevier, Russian Science Academy, IEEE, MDPI. Also in conferences which were supported by IOP Science, IEEE, and Springer. Also, these projects were supported by President of Russian grants, Russian Science Foundation, the Ministry of Higher Education and Science, and the Huawei company, which also provided the project for accelerating computations of this physics and from neural networks. Thank you for your attention. I'm ready to answer your questions.
Thank you. Do you have any questions? I have one question.
Yes.
Did you use quantum computer or simulators?
We use simulators in Penny Lane and Qiskit, but in one research which is not related to this presentation, we had access to IBM quantum computer, and this machine works tremendously faster than usual PC.
Okay, thank you. Thank you your great presentation and research. Thank you and welcome our city or country. I hope you coming our city will be meaningful for you.
I will visit again more than one time, I hope.
Okay, thank you. Okay, let's go. Kimler var ekan? Zoom'da? Ahmad Han Zoom'da tutuldu. Zoom'da.
In the program, there will be a presentation. This presentation, my colleague Valentina Staman had to present, but she unfortunately came not. She has family affairs to do. And can we count this report? But she cannot at the moment to report it.
You can. Yes?
No,
No.
no. Can we count this report in conference, but without report, without report,
Yes,
but
yes,
count?
yes. Okay. Вот кино тема. Professor Farooq, can you hear me? Professor Farooq. Yes. Qillarning daxlatlari bor ekan. Mana shunday ekan. Ahmadxon so'rachi. Boshqa hech kim qo'shilmadimi? Boshqa yo'qmi hech kim? Yo'q, shart emas, bizga qo'shilgan. Boshqa bo'lsa ham o'tkazaverishimiz kerak-da. Ha. Chiqib ketdi. Good afternoon, Professor Saidullayeva Shahrizoda. Can you hear me? Saidullayeva Shahrizoda. Can you hear me? Shu isqiribxona olib borib o'tiribmish. Darsga boshlaymiz keyin. Nariga borasizlar-da, to'rtburchak binoga borasizlar. Professor Saidullayeva Shahrizoda, can you hear me? Please switch off your volume. Yeah, on. You are muted, Professor. Bir kishi kirgan, gapirayotgan bo'lmayapti.
Kim sarlayapti?
Ha.
Bo'ldi, taklif qildi.
Bo'ldimi?
Ha, gapiring.
Ha.
Bo'ldi, saqlanib turib, to'xtab. Rahmat qizlar sizlarga.